Hey guys, I've been asked a few questions recently about the reversibility of reactions in relation to delta G and some of our thermodynamic principles. So what I'm going to do is I'm just going to record a quick video about that for anyone who has any questions. So I'll share my iPad screen. Give me one moment. So the first thing I want to really quickly recap on is this idea of reversibility and clarify some things around that for all of you. Okay. So the first thing is, what does it actually mean if a reaction is reversible? So when we talk about reversible reactions, what we're talking about is reactions which progress in both the forward and reverse direction. By contrast, when we talk about an irreversible reaction, reverse direction. When we talk about an irreversible reaction, we're talking about a reaction which only progresses in the forward direction. Something to make very clear about this, though, is that when we talk about an irreversible reaction, although it only progresses in the forward direction, that's not to say that it can't go backwards. Okay, so for an irreversible reaction, it can go backwards. It just requires a specific set of conditions or whatever it is to allow that to happen. Can go backwards under right conditions. So an example of that is photosynthesis and respiration. So respiration is a spontaneous reaction. It occurs without the input of energy. By contrast, photosynthesis requires the input of UV light and chlorophyll as a catalyst, right? So in that situation there, respiration can occur naturally, right? And it'll occur to completion. And then photosynthesis will only occur when we input UV light and when we use a catalyst. So we can see that they're both going to be complete or irreversible reactions because they don't occur at the same time. They both only occur one at a time, okay? So the next thing we can think about is what is the actual conditions of delta G which allow for a reaction to be reversible or not reversible, okay? So before we can talk about that, I actually want to distinguish this idea of delta G and delta G naught. Now, with this, what I'll say is we're going into a little bit more detail than you'll probably need, but it's something useful just to understand this concept. So delta G, right, is just our Gibbs free energy. Okay. Delta G naught, which is what you would have done most of your calculations with last year or in prelim, okay, is delta G. So it's your Gibbs free energy under standard states. So in terms of how we calculate these two things, how we calculate delta G naught is using the formula delta H minus T delta S. Okay, so it's equal to delta H minus T delta S. When we actually look at calculating delta G, so not delta G naught, it's similar but slightly different. So it's actually equal to delta H minus T delta S plus RT ln Q. And I'll explain what this means in a little bit of detail, but we can see there's actually this little bit of an extra part here. Something else I'd mention alongside that though, is we can actually think about that then as just equal to delta G naught plus RT ln Q. Okay. Now, I know I've talked about some stuff that's a little bit new, a little bit different, but before we go any further, the first thing I want to mention is what does it actually mean when delta G is equal to 0 and when it's equal to less than 0, etc. Okay. So the most common thing we see is that when delta G is less than 0, and we know that that means that a reaction is going to be spontaneous, okay? So when the reaction is spontaneous when delta G is less than 0, and that's what you would have talked about in Mod 4 in Year 11. The other new situation that we see is when delta G is equal to 0, And this is actually when a system is at equilibrium. Okay, so we know the system has reached equilibrium once the delta G is equal to 0. And notice that this is not delta G naught, it's specifically the delta G, because the delta G will change, whereas the delta G naught will be more fixed. So why does the delta G change? The reason the delta G changes is based on this last part here, which is this RT ln Q. Okay, so RT just is my gas constant, temperature, and then ln Q, which is this last component. So the big question is, what is Q? So Q is actually equal to my reaction quotient, okay, which you're going to look at in more detail next lesson. But at a simple level, the reaction quotient is just a ratio of my reactants to products. So a way of thinking about it is just equal to the concentration of products divided by the concentration of reactants. So what we can see is that the value of delta G is actually dependent on my concentration of reactants and products. Okay, and the value of delta G actually changes as my concentration of reactants and products changes. And what we know is that the concentration of reactants and products are going to continue to change until the value of delta G is equal to 0, because that's when my system is at equilibrium. So what it's trying to get to is a stage when delta G is 0, because that's equilibrium. And the way it does that is by changing the value of Q. Okay, so what we can think about then is, how does my system actually get to a stage when delta G is going to equal to 0? And there's two cases we can think about. The first case is when delta G is already approximately equal to 0. Okay, so when delta G is approximately equal to 0. And sorry, when my delta G naught is approximately equal to 0. Now, if delta G naught is approximately equal to 0, RT ln Q wants to be approximately equal to 0 as well. Okay, so if delta G naught is approximately equal to 0, RT ln Q must be approximately equal to 0 as well. Okay, now for RT ln Q to be 0, and this is relying on a little bit of your logs knowledge, and it's a bit more than what you guys would be expected to know. To achieve this, what we know is that we need Q to be approximately equal to 1. Because when Q is approximately equal to 1, we get ln1, and ln1 is just 0. Okay, so as I said, this is way above and beyond what you guys are expected to know. But because Q is approximately equal to 1, what we can see is that the concentration of products and reactants must be kind of similar. They must be in the same ballpark. They must be what we say is comparable, which means that both reactants and products are present in my reaction vessel, and I get both my forward and reverse reactions occurring. By contrast, if my delta G is very negative, so my reaction is spontaneous, it's very, very negative now, okay? My RT ln Q must be very, very positive in order for delta G to be equal to 0. Because remember, this has to cancel with this for it to be 0. For RT ln Q to be very positive, what I have to get is that my Q value is very large. Now for Q to be very large, my concentration of my products must be greater than my concentration of reactants, or much greater than my concentration of reactants. Effectively, what we get is that the concentration of reactants must become 0, okay? And the concentration of products ends up being some large positive number. And that's what actually happens in a complete or irreversible reaction, okay? Because in a complete or irreversible reaction, my reactants go to 0. So just to quickly recap on what I covered just then, okay? What we said is that a system will only reach equilibrium once delta G gets to 0. We know that we can calculate delta G using this equation, which you're not required to know, and it's beyond the prelim syllabus as well, okay? But it's actually dependent on the concentration of products and reactants. And what we said is that for a reaction to be reversible, delta G naught must be approximately equal to 0. And for a reaction, if delta G naught is not approximately equal to 0, so if it's very positive or very negative, the reaction will not be reversible because the concentration of reactants will actually have to be approximately equal to 0, and it will reach a static and not a dynamic equilibrium. Okay. So I hope that helps clarify some of that stuff. And I know it's above and beyond what you guys are expected to know. But if you have any questions about them, feel free to post it up and I'll answer them as best as I can. Okay. Hope that helps.